So if we add water, it's not just oxygen which is present, hydrogen is also present in oxygen, right? So to balance that, on the other side you have to add H plus ions. Increase or decrease in oxidation number in both the reactions must be equal. That means just now we calculated here, total there is a 6 unit change which is taking place. So if 2 molecules of water is added, how many H plus I have to add on this side? 2 into 2, it is 4, right? So 4 H plus is added. So this is your balanced redox equation. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So in the last session, we studied how to write stock notation, right? And the definition of oxidizing agent and reducing agent in terms of oxidation number. How in terms of oxidation number, we can determine whether the substance is undergoing oxidation and reduction. Then what is oxidizing agent and reducing agent in terms of oxidation number. As well as we studied the different types of redox reactions as well, right? So in today's session, we are going to discuss an important topic, that is balancing of oxidation reduction reactions. So you are familiar with what is redox reactions by this time, right? So we are going to balance redox reactions, okay? So you already know how to balance normal chemical equations, right? So it's quite different from that. We are going to study how we are going to balance a redox reaction, right? So there are two methods, oxidation number method and ion electron method. So let's begin with that. So two methods are used to balance chemical equation, and the first one is oxidation number method, another one is ion electron method. So the both of these methods we are going to study in detail, right? So let's begin with the first one, that is oxidation number method. So there are few steps that you have to follow in this procedure. So completing each of the steps, we will finally obtain the balanced redox chemical equation. Okay, so let's see. Balancing redox reactions by oxidation number method was developed by Johnson. Steps involved are, so we are going to see the steps, okay. The first step is write the skeletal equation. If not given, you have to frame it, of all the reactants and products of the reaction. So the first step is to write the skeletal equation. So what does the skeletal equation means is that if in the reaction which is given, if there is any water molecules which is represented, you have to not mention all that. That is what written is. If not given, you have to frame it. So that means that if in the problem or the question water molecules are given, you have to remove all that, okay. Water molecules, H plus ions, all those you not have to represent it. You don't have to represent it. Only the skeletal equation has to be represented. So that is the first step, right? Now second step is indicate the oxidation number of each element in the equation and identify the elements which undergo a change in oxidation number. So we already know how to assign oxidation number. We have studied the rules for that. So by assigning oxidation number, we have to determine which element is undergoing oxidation, which is undergoing reduction, right? Calculate the increase or decrease in oxidation number and identify the oxidizing and reducing agent. Fine. So once we get to know the oxidation number, we can identify which is the oxidizing agent and reducing agent. That's the third step. Fine. Now the next one is multiply the formula of the oxidizing and reducing agents by suitable integers so as to equal the total increase or decrease in oxidation number. So that means it is a redox reaction, right? So reduction as well as oxidation is taking place. So the next step is to multiply by a suitable integer the both equations so that the total increase and decrease in oxidation number will be the same. So once we start doing the problems based on that, this will be clear, okay. So that means that the next step is to equal the total increase or decrease in the oxidation number. So in both reactions, it must be equal. The change in or the increase or decrease in oxidation number must be equal in both the reaction, that is oxidation as well as reduction. Yes, next step is balance the number of atoms other than oxygen and hydrogen atom. So that means that apart from oxygen and hydrogen, that we will be balancing towards the end. In the last step, we will be balancing oxygen and hydrogen atoms. So before that, if any other atoms are unbalanced, you have to balance that. Okay, and the last step is balance hydrogen and oxygen atoms by using water molecules using hit and trial method. So how many ever oxygen atoms you require, that many molecules of water you have to add, and to balance that we will be representing H plus ions on the other side. So all of this, once we start doing the problems, you will understand. Okay, so in acidic medium, and neutral solutions. Okay, in acidic medium, what happens is first balance oxygen atoms by adding water molecules to whatever side deficient in oxygen atoms, and then balance hydrogen atoms by adding H plus ion to whatever side deficient in hydrogen atoms. So, if it is in acidic medium, if the question it is given that it is in acidic medium, the reaction is taking place in acidic medium, then what we have to do in the final step, oxygen atoms must be added to the side which is having oxygen atom deficient. So how can we add oxygen? Not directly, it must be present as a compound, right? So what we will be adding it in the form of water molecules. So if we add water, it's not just oxygen which is present, hydrogen is also present in oxygen, right? So to balance that, on the other side you have to add H plus ions. So this is in the case of acidic medium. Now for basic medium, first balance oxygen atoms by adding water molecules, okay, to whatever side is deficient in oxygen atoms. The hydrogen atoms are then balanced by adding water molecules equal in number to the deficiency of hydrogen atoms, and on equal number of OH minus ions are added to opposite side of the equation. So in acidic medium we will be adding H plus ions, and in basic medium we will be adding OH minus ions to balance the water molecules or balance the number of oxygen atoms. So I hope it is clear. So let's move on to the problems. So first one, let's take the example, balance the following redox reaction by oxidation number method. Okay, so the equation is already given to you. Cr2O7 2 minus plus SO3 2 minus gives Cr3 plus SO4 2 minus plus H2O. Okay, and it is given in acidic medium. So we know it is given in acidic medium. First we have to balance the number of oxygen atoms by adding water molecules, and on the other side we are going to add H plus ions. All that we are clear. So step by step we are going to balance the equation. So as discussed, the first step is to write the skeletal equation. So you can see a water molecule. Now you don't have to consider that. So once you write the skeletal equation, you can see Cr2O7 2 minus, SO3 2 minus, Cr3 plus and SO4 2 minus. You don't have to write the water molecule there. I hope it is clear. So that is your first step. Write the skeletal equation, removing the water. Okay. Now moving on to the step 2. Assign the oxidation number and find the change in oxidation number for the atoms undergoing oxidation and reduction. So that's the second step. We are going to find out the oxidation number. So first let's take Cr2O7 2 minus. So we have already discussed how to calculate the oxidation number, right? So for chromium we don't know, so we have to take it as X. So 2X plus, for oxygen it is minus 2, right? 2x plus 7 into minus 2 will be equal to minus 2, right? It's a charged species. So 2x minus 14 is equal to minus 2, 2x is equal to 12, x is equal to plus 6, right? So plus 6 is the oxidation number. That's what is written here. Plus 6 is the oxidation number for chromium here. Now moving on to SO3 2 minus, let's calculate for that SO3 2 minus. Okay, for oxygen it is minus 2, for sulfur it is x. So x minus x plus 3 into minus 2 will be equal to minus 2. X minus 6 will be minus 2. So x will be equal to plus 4, right? So we got the oxidation number for sulfur also. Now moving on to Cr3 plus, it is an ion. So Cr3 plus means whatever the charge present on the ion, that will be its oxidation number. So for chromium here it is plus 3. Now the last one is SO4 2 minus, SO4 2 minus, again x, for oxygen it is minus 2, right? So x plus 4 into minus 2, there are 4 atoms. So 4 into minus 2 will be equal to minus 2, x minus 8 is equal to minus 2, x will be equal to plus 6, right? So here for sulfur it is plus 6. So we calculated the oxidation numbers. So here it is plus 6, plus 4, plus 3 and plus 6. So now what is the next step? We have to identify which is undergoing oxidation and reduction. So in here you can see here from plus 6 for chromium, from plus 6 it is reducing to plus 3. So when the oxidation number is decreasing, what is it? Yes, when oxidation number is decreasing, it is undergoing reduction, right? So you can see here reduction is taking place. And sulfur from plus 4 it is increasing to plus 6. Oxidation number has increased. So what has happened here? Oxidation has taken place. So what did we do in the second step? We calculated the oxidation numbers and we identified which is undergoing oxidation and which is undergoing reduction. Now moving on to the next step, equalize the change in oxidation number for both the atoms by multiplying with suitable integers and balance the number of atoms other than oxygen and hydrogen. Okay, so before balancing oxygen and hydrogen atoms, we need to balance other atoms. So before that, we have to multiply with a suitable integer so that the total decrease and increase in oxidation number must be same. So what does that mean? Let's write these two reduction and oxidation reaction separately. So let's write the reduction reaction which is taking place. So Cr2O7 2 minus, we know that it is in +6 oxidation state and here it is +3 oxidation state. So reduction is taking place. Let's write down that reaction. Cr2O7 2 minus is getting reduced to Cr3 plus. Right. So this is the reduction reaction which is taking place. Here it is in +6 and here it is in +3 oxidation state. So by how many units this decrease is taking place? You can see that it is by 3 units, right? 3 units change is taking place, right? Okay, but there is one more point you have to remember. This 3 unit change is for 2 atoms of chromium, right? For each atom, there is 3 units of change. But how many are there in the reactant side? It is Cr2O7 2 minus, right? So for each atom of chromium, there are 3 units of change. So it is Cr2 here and only 1 chromium there. So what we have to do? We have to multiply this by 2. So you get 2 Cr3 plus. So that is the way we have to balance in here. So what does that mean? We have multiplied this equation by 2. So totally now in the reduction reaction, there is a 6 unit change which is taking place. Okay. Why did we multiply here by 2? It is because, right, you can see Cr2 here. It is for 1 atom of chromium, there is 3 units change. For 2 atoms, then it will be 6, right? So we multiply on the product side by 2. Okay. Now we are going to write the oxidation part. SO3 2 minus gets converted into SO4 2 minus. So here it is in plus. So here it is in +4 oxidation state. Here it is in +6 oxidation state. So by how many units increase is taking place? 2 units, right? 2 units increases taking place. Right. So now we can see that here and here the sulfur number is same. So there is no need to multiply with anything as of now. So now the next step which we were discussing now, which is the third step, the increase or decrease in oxidation number in both the reactions must be equal. That means just now we calculated here total there is a 6 unit change which is taking place. But here there is only 2 units change which is taking place. That means we have to multiply this equation by 3. So that means that we are going to multiply this whole equation by 3. Why? Because yes, here you are getting 6 unit change. You need 6 unit change here as well. So multiplying 2 into 3, we'll get 6 unit change, right? It means what? We are going to multiply 3 here as well as 3 here. So finally, what is your equation? Cr2O7 2 minus gives 2 Cr3 plus, right? So there is a 6 unit change. And here it is 3SO3 2 minus giving 3SO4 2 minus. Okay. So this is the oxidation and reduction reaction. So in both these cases, how many changes in units are there or how many increase or decrease? Yes, it is 6 units. So that is what is together which is written here. Cr2O7 2 minus plus 3SO3 2 minus, right? It is multiplied by 3 and 2 Cr3 plus and 3SO4 2 minus. So till here I hope it is clear. So we balanced all other atoms other than oxygen and hydrogen and we balanced the change in oxidation number also. Now the last step is add H plus and water to balance oxygen and hydrogen atoms in acidic medium. So what do we have to do if it is in acidic medium? We have to add water molecules to the side which is deficient in oxygen atom. So now let's calculate the number of oxygen atoms on either side and find out which is having lesser number of oxygen atoms, and we are going to add the appropriate amount of number of molecules of water. Okay. So in here you have 7 atoms of oxygen. Here 3 into 3, 9. So that means total of 16 oxygen atoms are present here. And on this side you can see 3 into 4, right? 12 atoms of oxygen are present. So you can see that on the product side you have lesser number of oxygen atom. It is 16 here and it is 12 there. So if we add 4 more atoms of oxygen, the number of oxygen atoms will be balanced. So how many moles of or how many molecules of water we have to add? 4, right? So we add 4 H2O here. So now if we count the number of oxygen atoms, it will be same because 12 here plus 4 we have added now. So that means 16 here, 16 here. The number of oxygen atoms is balanced. But now there is a problem. The number of hydrogen atoms is not balanced. So what do we add? We add the appropriate amount of or appropriate number of H plus on the other side, right? It has to be balanced. So how many hydrogen atoms are here? 4 into 2, right? 8. So we add 8 H plus on this side, right? On the reactant side. So totally the reaction will be balanced. So I hope it is clear. So this is how we are going to balance redox reaction. Let's take another example. Okay. So balance MnO2 plus Br minus gives Mn2 plus Br2 plus water in acidic medium. So here also first step is to write the skeletal equation. So in skeletal equation what you have to remove? No need to represent the water molecule here. So this is your skeletal equation. That's the first step. It is easy. Now the second step is we have to assign the oxidation numbers and identify which is undergoing oxidation and reduction. Okay. So you can see here MnO2. MnO2. For oxygen it is 2 minus. So X plus 2 into minus 2 is equal to 0. X will be equal to plus 4. Right. For here, for manganese it is plus 4. Br minus, of course, minus 1. Whatever is the charge on the charged species, that charge will be itself the oxidation number. Now Mn2 plus also it will be plus 2 and Br2, bromine in its elementary state, it will be again 0. Right. Okay. So till that it is clear. Fine, the oxidation number is being calculated. Now we have to identify which is undergoing oxidation and reduction. So manganese from plus 4 it has reduced to plus 2. Oxidation number has decreased. So that means it is undergoing reduction. And bromine from minus 1 it has increased to 0, right? Minus 1 to 0. The oxidation number has increased. So here it is oxidation which is taking place. Okay. So that is being identified. Now what is the third step? We have to balance or equal the total decrease and increase in the oxidation number. So we have to see by how many units it is going to increase or decrease. So let's write down the oxidation and reduction reaction separately here. MnO2 is reduced to Mn2 plus. Here it is plus 4 and here it is plus 2. Okay. So in this reaction, as you can see here, it is MnO2 and Mn2 plus here. Okay. So you can see here by how many units oxidation number is decreasing. It is decreasing by 2 units, right? So it is clear in this side because there is nothing else to be multiplied here because it is only 1 atom of manganese here, 1 atom of manganese here. So it is reducing by 2 units oxidation number. Now let's write down the oxidation part. Br minus is getting oxidized to Br2. Right. Here it is minus 1. Here it is 0. Okay. So now again like in the previous problem, there's a small point you have to remember. It is Br2 here and Br here. So what you have to do? You have to multiply it by 2. Right. So that means that actually how many units it has been increased? Only 1 unit. Right. So now what did we do to balance the number of bromine atom? We multiplied by 2. Okay. So now what does that mean? Here also how many unit changes there? 2 units. Here also how many unit changes there? 2 units. Now it is balanced. So I hope it is clear. As it was Br2 here, we multiplied the bromine by 2. I hope that is clear. So now that the number of bromine atoms is balanced also, the oxidation number change is also balanced. So we got the equation. So that is what is written here. MnO2. Right, MnO2 here and Mn2 plus. That is also written here. And how many bromine? 2 Br minus and Br2. So this is the third step. Right, by calculating the oxidation number, the change in oxidation number, we balanced it. So that was the next step. Now what is the last step? We have to balance the number of oxygen and hydrogen atoms. So we have to see the number of oxygen atoms on either side. So let's calculate on this side how many are there. You have 2 here. Right, and here you don't have anything, it is 0. So what we have to do, you have to add 2 water molecules on the product side, which is being added here. So if 2 molecules of water is added, how many H plus I have to add on this side? 2 into 2, it is 4, right? So 4 H plus is added. So this is your balanced redox equation. So I hope it is clear. So in the next class, we are going to study the half reaction method in detail, few more examples, ion electron method, and the applications of redox reactions. So I hope the concepts that we have cleared in this session is clear for you. So that's all for today. Thank you.